see. I think it is. Okay, great. Awesome. So let's start with some examples. Find y prime. I mean, I avoided all the easy examples. We just went straight forward to the slightly more challenging ones. Why? And the third one is a bit easier, I guess. Let's make it slightly harder. Okay, great. Let's get started. So these are fair game questions. Find y prime in each of the following cases. So what is how do we proceed in this one? Everybody, chain rule, right? So here what do we have? We have a composition inside a composition inside a composition inside a composition inside a composition, right? So let's try to look at the first one. So what is the function, the last function you're applying, or the layer that you see at the beginning? Like outside, like the most outer layer. What is it? It's everybody is it? Do we see this or not?
Yes.
Yes? So what is y prime? So first I start y prime. Derivative of root t is 1 over 2 root t. So it's 1, 2 root sine square root of secant x. Then, after the square root, what is the layer after the square root? It's a sine, right? Square root of sine of something, right? Sine of something. What's there of the sine function? It's the cosine. So it's cosine of square root secant x. The layer after, what is it? Is a square root. So it's the derivative of root t is 1 over 2 root t, so it's 1 over 2 secant x. And then what's the layer after? Is the secant of x, so the derivative of secant tan. Okay? Are we good? Everybody, are we good?
Yes.
Okay, any questions on this? Is that fine? Is that good?
Yes.
Any questions? Yeah? I mean, what you can do is that you can cancel the secant and the square root secant. Okay?
If we're a long answer, should we leave it at that long?
It depends on if they say simplify, you have to simplify. If they say do not simplify, you can leave it like that. Okay? Are we good here? Yes? Good. Everybody this side, are we fine? Okay, great. Let's move on to the second one. What is y prime? What is the last operation you're doing? It's a squared, right? What's the root of t squared? It is 2t. So what's y prime is 2 t. T is sine, cos, square root, whatever that thing is, right? 2 sine, cos, square root, sine, pi, x squared. What's the layer after the square? Please raise your hands. In the back, yeah? Sine, what's the root of sine? Cosine, so I have cosine of cosine square root sine of pi x squared. Now what's the layer after the sine? Who, please raise your hand, yes? Cosine, what's the derivative of cosine?
Negative sign.
Negative sine, so this is times here. Times negative sine square root of sine pi x squared. Now what's the layer after cosine? Please raise your hands. Please raise your hands. Yeah? Square root, thank you. So square root, what's the derivative of root t? It's 1 over 2 root t, so it's 1 over 2 square root sine pi x squared. Then what? What's the layer after the square root? Please raise your hands. Someone else? Yes?
Would be sine of pi x squared, which the derivative of that would be cosine pi x squared.
Times?
Times the inside of that would be pi x squared. Take the derivative of that, that's 2.
Awesome. Thank you very much. So you finished it for us. Okay? Are we good here? Yes? One over two sine pi x squared to the negative 1/2. That's fine. Okay? You should expect this level of difficulty. Yes, sir.
If they give it to you the root and you don't respond in the root, like if you reduce the 1/2, is that going to be dog hard?
Yes. No, that's fine. Yeah. Any questions here? Are we good? Okay, let's do the third one. The third one is the easiest. Okay, who wants to volunteer? Or do you, well, I mean, I don't think we have the luxury of time, so like we can just do it together. So what's the outer layer here? Please raise your hands. Yes? The third power. So you have a t cubed. What's the derivative of t cubed?
3 times t to the power 2.
3t squared, thank you. So y prime is 3 sine of cos of tan x squared to the power 2. So I'll just put the power 2 here. The layer after, what is it? Please raise your hands. Yes? Sine? What's the derivative of sine? The derivative of sine is? Cos. So times. Okay, this is the times here. Times cos of tan x squared. What's the layer after the cos? What's the layer after the sine? Please raise your hands. Yes? What's the layer after? Cos? What's the derivative of this? Okay, thank you. So it's times. All of this is times just because I don't have space. Minus sine of tan of x squared. What's the layer after cos? Please raise your hands. Yeah? Tan? What's the derivative of tan? Secant? Squared, thank you. So it's secant squared of x squared. And let me finish this. Okay, do we see this? Everybody, do we see where this comes from? Remember, we have seen the formula for the chain rule. Like if you have like 5 compositions or 4 compositions or 3 compositions, you differentiate layer after layer after layer after layer, right? You remember this or not?
Yes.
Okay, so please keep this in mind. This is important. You should be able to differentiate these things. You may be able to do them in one step. Okay, if you do them in one step, it means you master the material very well. Now, if you do in one step and you mess it up, that's a problem. So if you're going to mess it up, please write your steps, write your reasoning. Okay? Great. Awesome. Let's do few more. Okay, so find the equation. Find an equation. Or you know, let's do it here. Okay, so let's do one. At the point, let's see, at the point. Okay, this should be easy, shouldn't it? Should it not be easy or should it be easy? This should be very straightforward, right? Or not? Everybody, if you have a question like that, you should get it. Okay? Great. So how do we start? We start by differentiating. So what is the root of 5 root x? So it's a composition of two functions. You know, 5 to the power t and root x. What's the root of 5 to the power t? Is ln 5 with respect to t. It's ln 5 times 5 to the t, right? So 1 y prime is ln 5 to the root x. What's the root of root x? It's 1 over 2 root x, right? Yes or no?
Yes.
Yeah? You should know your derivatives by heart. Okay? So, or you know not to derive them. Great. Now, how do I find an equation of the tangent line? What's y prime of 4? It's ln 5 times 5 to the root 4 over 1 over 2 root 4. What is that? It's 25, so it's ln 5 times 25 over 4. So what is an equation of the tangent line? Y prime of 4. Oh well, I don't like this, you know, 2 y's. So ln 5 times 25 over 4 times x minus 4 plus 25. Okay, I don't think it's, I mean, you can simplify. Okay. Yes.
Are we expected to simplify? Or can we leave it in the first one?
The question will be clear. Okay? If you need to simplify, you'll just have to simplify. If not, then no.
Will we need to know different forms, like standard form of the line and y with limits for speed, or can we put it in any form?
So if you find an equation of the tangent line, you could keep it this way.
Okay.
Okay? Unless it simplifies very nicely.
Yeah.
Okay, I'll leave it. You judge, right? Now, what's an equation of the normal line? If the slope of the tangent line is f prime of a, and f prime of a is non-zero, what is the slope of the normal line? Someone please raise your hands. Yes? Negative 1 over f prime of a, right? Yeah, do you remember this or not? So if the tangent line has non-zero slope, f prime of a, then the normal line has slope minus 1 over f prime of a. So what's an equation of the normal line? Now the normal line it's minus 1 over f prime of a, so it's y is equal minus 1 over ln 5 times 25 over 4 times x minus 4 plus 25. So what is that? This is just minus 4 over 25 ln 5 x minus 4 plus 25. So for example here, by simplifying, you may not get something nice. Okay, you will not get something nice. But I mean, if the question asks you to simplify, you'll have to simplify. Okay, so far so good? Any questions on this? Did we review this? Okay, great, awesome. Let's do the second one. So I'm not given the y value, so I have to find an equation of the tangent line at the point where x is equal to 0. So y is equal to x squared minus 1 over x squared plus 1. What is y prime here? What do I use for y prime? Is y prime complicated? Is y prime complicated or not? No. So who can help me with y prime? Who volunteers for y prime? Please raise your hand if you want to volunteer for y prime. Preferably someone who hasn't said anything today. Y prime? Yeah?
Quotient rule?
Quotient rule, yeah, do you want to help?
Sure. Do 2x, the derivative of this rule,
Yeah?
times Arnold's quotient,
Yeah?
plus 1. And the derivative of x, the derivative of the second one, times the first function, all over the second function.
Thank you very much. Great. Let's simplify that. So you see what happens. You have 2x minus 2x, so you get 4x over x squared plus 1 squared. So you need to find the tangent line at the point where x is equal to 0. Now, do you have the y value, or we don't have it? But is it a problem if we don't have it, or we can find the y value? We can find the y value. What is the y value here? What is it? Negative 1. Thank you very much. So y of 0 is 0 minus 1 over 0 plus 1. Again, I mean, having seen the midterm, I think I can tell you it's straightforward, like just like that. It may be a bit long, but it's actually straightforward. Okay? So things like that you should be able to get. Okay? If you have a quotient rule, don't panic. You may get a nice quotient rule. Don't panic, okay? Great. Yes? Pardon me? Okay, so at the point where x is equal to 0, what is the value of y? If x is equal to 0, y is equal to 0 minus 1. Okay? Now, what's an equation of a tangent line? Y is equal, what's y prime of 0 in that case? Y prime of 0 is equal to 0. So what can I say about the tangent line? Y prime of 0 is 0. So tangent line, horizontal in that case, this is y is equal to minus 1. Now, what can I say about the normal line? If the tangent line is horizontal, what can I say about the normal line? It's vertical. Passing through the point 0 minus 1. So what's an equation of the normal line? X is equal to, someone said this, yeah? X is equal to 0. Exactly. Normal line would be vertical. Could we apply the result we have applied here? Minus 1 over the slope? Or we had a condition on the slope to be able to apply this. What's the condition we had on the slope? To be minus 1 over f prime. We said that the slope of the normal line is minus 1 over f prime of a if f prime of a is non-zero. Can I apply the result here or not? No, because f prime of 0 is 0. Okay? Is that clear, everybody? Is that fine? Are we good? Great. things like that are very important. Okay, let's do one more. Well, now, let's move on to implicit differentiation. This is from your book. This is from section 3.6 of the book. 3.5 maybe, 3.5. If g of x plus x sine of g of x is equal to x squared, find g of 0 and g prime of 0. We have done question like this before. Okay, what do you suggest? If I want to find g of 0, what do I have to do? Let me try to plug in x in the original equation. What do? I plug in x is equal to 0. Let's plug in x is equal to 0. To find g of 0, we have that g of 0 plus 0 sine of g of 0 is equal to 0 squared. So this is g of 0. This is 0 is equal to 0. So g of 0 is equal to 0. Now in order to find the tangent line, not the tangent line, g prime of 0, what do I have to do with this equation? I have to, do I have any derivative of g appearing here? No, so I have to let the derivative appear, right? How do I do this? By? I differentiate, right? Are we good here? We differentiate, so d by dx, implicit differentiation or the chain rule. Okay, what's the derivative of that thing? What's the derivative of g of x? It's g prime of x, right? Plus x sine g of x. How do I differentiate that? What is that? That's a product. Okay? What's the derivative of x sine g of x? Who wants to help? Please raise your hand. I'd like to see new hands raised. Yes, in the back? Yeah.
Sine x plus x cos x.
Well, you have a g of x here. This is not an x.
Oh, wait, are you looking for the product rule?
Yeah, x sine g of x.
Oh, x
Yeah.
sine g of x. So sine g of x plus x cos g of x.
Great, so I differentiate x and I keep sine g of x fixed.
Yep.
Plus, I keep x fixed and I differentiate sine g of x. What's the derivative of sine? So it's a chain rule. Sine g of x, what's the derivative of sine? It's cosine. Cosine g of x. And we forgot a small thing, but important. The g prime of x at the end, right? The derivative of sine g of x is cosine g of x times g prime. Okay? Great, thank you. Times 2x, is equal to the derivative of x squared, which is 2x. Now what do? I plug in x is equal to 0. So g prime of 0 plus sine of g0 plus 0 prime of 0 is equal to g of 0 is 0, right? So it's minus sine of g0, so it's minus sine. Okay, great. So g prime of 0 is equal to 0, and g of 0 is equal to 0. Okay? Did I mess it up? I think that's good. Yeah, I think that's good. Is that good? Yeah. Okay. Great. Let's do one more. On implicit differentiation, so f x squared plus 4xy plus y squared is equal to 13. Find an equation of the tangent line at 2, 1. 2, 2, 2, let's see. 2, 1, so you get 4 plus 8. Yeah. Okay. Now, what is that? That's an exercise in differentiation. What type of differentiation? Implicit differentiation. Okay, we gotta know this very well. So implicit differentiation is very important. Chain rule is very important. Great. So how do we proceed here? We differentiate with respect to x. Great. Who wants to volunteer? So d by dx of both sides. Okay, who can volunteer? Who can help me? Yes, so, yeah?
Yeah, so you have 2x.
Yeah, just one second, thank you. Sorry. Yes. It's 2x, yes?
Plus 4y.
Plus 4. Okay, could you reason how you're doing it at the same?
I'm using the product rule for the 4xy.
So 4xy is a product rule. Very good. So plus 4. The derivative of x times y. So derivative of x, what is that? 1. So it's 1 times y plus
4xy prime.
plus xy prime. Thank you. Plus.
And then I just walked to the other side, so I had minus 2x minus 4y.
No, just line by line. One by one.
And then I had plus
The derivative of
2y y prime.
plus 2y y prime. Thank you. Is equal to 0. Okay, are we good here? Everybody, are we good here? Please, if this is not clear, please let me know. Are we good here? Okay, do not forget to differentiate the y as a function of x. Okay? Great. Yeah? Great. Now I can solve for y prime. So let's solve for y prime. So I have 2x plus 4y plus 4x y prime plus 2y y prime is equal to 0. Now let's write this. It's 2x plus 4y plus 4x plus 2y times y prime is equal to 0. Y prime is then equal to minus 2x minus 4y over 4x plus 2y. Divide by 2, so you get minus x minus 2y over 2x plus y. Is that what you got? Is that what you got? Yeah? Yeah? You got this as well? Okay. So y prime of 0, or well, y prime of 2, what is y prime of 2 equal to? At x equal 2, y prime at xy equal to 1, right? x is equal to 2 and y is equal to 1, what is y prime? Y prime is minus x minus 2y, minus x minus 2y, and 2 over 2x plus y. So it's minus 2 over x plus 2y. Is that it? 2x plus y. Okay, those numbers are confusing. So 2x plus y, so it's 4 plus 1. So you get minus 4 over 5. So what is an equation of the tangent line? Y is equal to minus 4 over 5 x minus 2 plus 1. Okay, so you get minus 4 over 5x plus 8 over 5 plus 1, so plus 13 over 5. Okay, so let's double check. If x is equal to 2, y would be equal to 1. Awesome. Okay? Is that clear? So far so good? Yeah? Are we good here? Yeah? Everybody, any questions? Any questions? Great. Awesome. I mean, we have 20 more minutes. I mean, I have 2 more problems, but I think they're, well, let's do one. Do you guys have questions about anything or not? Do people have questions? If people have questions, I can do one more problem and get your questions. If not, I can just continue doing problems. What is your preference? Yes, sir. Yeah, we're gonna do squeeze theorem. Okay, so you want intermediate value theorem? We can do that. We can do that. Yes, sir. Yes. Who had a question? Yes. Oh, thank you.
If we substitute the point much earlier before we isolate y prime above,
You could do that. You could do that. Yeah. But sometimes if I ask you for y double prime, it's better to have this one done. Okay? So if a question is find y double prime, it's better to use this form. Okay? Boom. Okay? But the idea is that don't substitute it here and differentiate. After you differentiate, substitute it. Yeah. Okay? Great. Let's do more questions. Find the asymptotes. To y is equal e to the minus x sine e to the x. Okay. Yes?
Sorry, I didn't ask this earlier. Can we do later a problem with inverse trig?
We have no inverse trig on the midterm. No inverse trig. No. No. No log, no logarithmic, no inverse trig. Unless you want it, you can still edit it. Okay. Yeah. Great. So what is y e to the minus x sine e to the x? Great. What can I say about this function? But inverse trigs are easy, right? Inverse trigs are not very hard. Those are the... No? I mean, these are just derivatives. Anyways. So, what is... So how many asymptotes did we see? We saw 2 types of line asymptotes, vertical and horizontal. Now, find the asymptotes to y is equal to e to the minus x sine e to the x. Great. So for the vertical asymptotes, do I have any or not? No vertical asymptotes. What's the reason behind this? This function, where is it defined? Yes? On all the real numbers. And what can I say about this function? It is continuous, right? So f of x e to the minus x is defined on R and is continuous on R. minus x are continuous on R. You see that? Sine t is continuous on R. So when you and e to the x is continuous on R. When you compose two continuous functions, you get a continuous function. When you multiply a continuous function by a continuous function, you get a continuous function. Okay? This x arrows sine e to the x, this means that the function that assigns to x sine e to the x. Okay? X arrows means f of g of x equals something. Okay? Great. Now, so y equal f of x has no vertical asymptotes. Now, what I would be looking for now are the horizontal asymptotes, if any. So the horizontal asymptotes, how many limits do I have to compute? Two limits. X goes to plus infinity and x goes to minus infinity. Which one do you want to start with? Who volunteers? So who wants to start? Start with infinity, plus infinity. Let's start with plus infinity. At plus infinity, or at infinity, the limit as x goes to infinity of e to the minus x sine e to the x. What's the first thing you do? Immediately, what's the first thing you do? You plug in. So you get e to the minus infinity. What is e to the minus infinity? 0, right? E to the minus infinity is 0. Now sine of e to the x. This is sine of kind of infinity, right? Does sine of infinity exist? No, right? Sine keeps oscillating. So does sine t have a limit as t goes to infinity? No. So sine e to the x does not have a limit as x goes to infinity. So now we're stuck. Great. What do we have to do here? What do you have to do? Squeeze theorem. So, limit of x goes to infinity of sine e to the x does not exist. We have to do something else. We have to use the squeeze theorem, right?
Yes.
Great. Now what do I know about sine e to the x? Sine e to the x is between what and what? For all x, sine e to the x is between 1 and minus 1. Great. Now what do I know about e to the minus x? What's this quantity? Is it positive or negative? E to the minus x is always strictly positive, right?
Yes.
E of something is always a strictly positive number, whatever that something is. You agree or not?
Yes.
Since e to the minus x is strictly positive, for all x, minus e to the minus x is less than e to the minus x sine e to the x is less or equal than e to the minus x. So far so good. I just multiplied by e to the minus x all the inequalities. Yes or no?
Yes.
Okay? Great. Now, what do I do here? What's the limit as x goes to plus infinity of e to the minus x? It's e to the minus infinity. What is that? 0. Now look at the left hand side. Minus e to the minus x will also go to 0. We see this or not?
Yes.
Okay? Is 0. And the limit x goes to infinity of minus e to minus x is also 0. Hence, by squeeze, the limit as x goes to 0 of as x goes to infinity is equal to 0. So horizontal like that. Do not just try to make up your own laws. If you have a cosine that the limit does, where the limit does not exist, it's probably a good idea to use the squeeze theorem. Okay, where you so don't try to just say cosine of infinity is 0. Okay, or cosine of infinity belongs to minus 1, 1. Or cosine of 1 over 0 belongs to minus 1. All of this will lead you to a 0 immediately. Like 0. Okay? Yes?
When we're making our inequality for the squeeze theorem, do we need to write each step of it? First say negative 1, 1, and then say...
Exactly, yes. You have to write each step. Yes, sir. Yes. Okay. Now let's look at the vertical as minus infinity. Okay, great. Here, how do we proceed? How do we proceed here? Okay, let's try with squeeze. Will squeeze give me a... Will squeeze give me a thing? So let's try. I mean, squeeze will still give me these two bounds, right? Great. Squeeze theorem will give me these two bounds. Now, if x goes to minus infinity, e to the minus x will be e to the minus minus infinity. So it will be e to the infinity, which is infinity. Now, e to the minus x is infinity. Minus that is minus infinity. So this says that the limit, if it exists, belongs to minus infinity and infinity. Does squeeze do anything here? No. Squeeze tells me that if the limit of the right hand side and the left hand side are the same, then the limit of the middle exists and is equal to the limit of the left and the right hand side. Now, here, e to the x as x goes to minus infinity, where does it go? E to the minus infinity is what? 0, right? So let's just write this as before. Can I do this? Everybody, can I do this?
Yes.
E to the minus x is 1 over e to the x. Great. Now e to the x will go to 0. So I kind of have sine t over t as t goes to 0. Right? Look at the inside. If you let t be equal e to the x, t is going to 0 because e to the x is going to 0 as x goes to minus infinity. So what is this limit? 1. We see that or not?
Yes.
You got it? You what? Very good. We see this or not?
Yes.
This is equal to 1. We should justify, always justify. Okay, so horizontal asymptote at minus infinity is y is equal to 1. Okay? Yes?
Wait, shouldn't the limit kind of the size of e to the x, sorry, the x, shouldn't that be limit as x goes to 0?
X goes to negative infinity. So if x goes to negative infinity, what can you say about e to the x? 0. Okay? So replace the x by replace e to the x by t, right? Where will t go to? 0. Okay? So, is that clear? Okay? Great. So what's the other important limit that you have to know? 1 over 1 minus cosine x over x is equal to 0 as x goes to 0. Okay, you should justify like that. Should you have a question like this, you should justify like that. You should clearly state any results that you are using. Yes, sir?
How come we couldn't do this for positive?
Well, for positive infinity, e to the x would go to infinity. It wouldn't go to, it's not going to 0, so you cannot apply that result. Okay? Great. With think I have 5 more minutes. I had like another question. Find f and find f prime and its domain using the definition of the derivative. Do we need to do this or not? Should we do one like that? Okay, so let's let f of x find f prime using the definition. Okay, what is f prime of x? What is, I have to use the limit definition. Of course, here, if you use the formulas, then you get a 0. Okay. Okay, so how do we have to, I mean, I don't think I'll have time to finish it. But do you know how to do this or not? Everybody, do you know how to do these things? Yes or no? Let's try to do it. So what you have to evaluate? You have to evaluate the limit as h goes to 0 of f of x plus h minus f of x over h. Okay? So this is just the limit. As h goes to 0 of what? 1 over root of x plus h plus 1 minus 1 over root of x plus 1 over h. Let me do this quickly. Okay, we just write this nicely. Root x plus 1 minus root x plus h plus 1 over h root x plus h plus 1 over root of x plus 1. Now what do you do here? You plug in, you get 0 over 0. So you multiply by the conjugate. Sorry, I'll just do it a bit quickly. You multiply by the conjugate on top and on the bottom. Okay? And then what do you get? You get, it's the limit as h goes to 0 to x plus 1 minus x plus h plus 1. So you get a minus h over h square root of x plus h plus 1 square root of x plus 1 times the square root of x plus 1 plus square root of x plus h plus 1. You cancel out the h's, so you get minus 1 over square root x plus 1 squared. So you get square root of x plus 1 square root of x plus 1 times 2 square root of x plus 1. And then you get minus 1 over 2 x plus 1 to the 3 halves. Okay? Is that the same thing you get using the limit rule? Is it using the derivative rules? Yes. Okay. So thank you, and